All available units pursue and capture Will Nye.
William Lehan.
The Science Guy.
William Lehan, the Science Guy.
Will.
William Lehan.
Science news.
William Lehan.
Inertia is a property of matter.
Will Nye, the Science Key.
Will. William Lehan.
The Science Guy.
Do you have him ready?
We have him in the holding room.
You think you can get him to talk?
Yeah, these TV personality types, they're like children. Get them to squeal. They tell me you're enthusiastic about science. Is that true? Why am I here? Non here has a science project due tomorrow. And he tells me, you're the best guy in the biz.
Why are you
You're lucky the Russians didn't get to you first, okay? I'm sorry, I'm being short. Look, we need to know everything you know about photosynthesis and the Calvin cycle, or you're never going to see your kid again. You monsters. I'm a monster? Do you know how hard AP Bio is? Huh? Look, we're going to need you to make a 3 to 5 minute, perky, educational video catering to the K through 12 audience.
Oh, go to hell.
Did you just hear that, Don? Ah, calm down. Look, you want to go home, you want to see this adorable little kid of yours. But that's not going to happen until you tell me what I want to...
The chloroplast is composed of several areas. One is the thylakoid, which is a membrane-enclosed structure, and the other is the medium around it, which is the stroma. The first part of photosynthesis, the light reaction, takes place in the membrane of the thylakoid. The first stage of the light reaction takes place in photosystem 2. A photon of light is absorbed by a molecule of chlorophyll, raising an electron into a higher energy level. The electron then falls back to its ground state, producing heat and exciting a nearby molecule, which continues the process until it reaches a pair of chlorophyll molecules which are excited and produce an electron. The excited electron is then captured by the primary electron acceptor. The oxygen evolving complex then uses an enzyme to catalyze the splitting of water into H+ ions, 2 electrons, and an oxygen atom. The 2 electrons reduce the positive charge on the P680 chlorophyll molecules. The H+ ions are introduced into the thylakoid lumen, and oxygen atoms form O2 molecules and are released. The electron transport chain then passes an electron from photosystem 2 to photosystem 1. As electrons pass through the cytochrome complex, H+ is pumped into the thylakoid lumen because of decrease in electron energy state, increasing the proton gradient between the stroma and the lumen. In photosystem 1, a photon excites the electrons in the central pair of chlorophyll A molecules, creating a positive charge. The new positively charged molecules act as acceptors for electrons coming from photosystem 2. Electrons are collected by the electron acceptor and passed on to the protein ferredoxin, which acts as an electron carrier to transfer electrons to ferredoxin NADP+ oxidoreductase, which reduces a molecule of NADP+ into NADPH with an H+ proton. Meanwhile, there is a high concentration of hydrogen protons in the lumen. These ions move along a gradient from high to low concentration through the ATP synthase. The movement of the protons turns the head of the ATP synthase, which converts chemical energy to mechanical, affixing a phosphate group onto ADP, producing ATP. The products of the light reaction are NADPH and ATP, which go on to the Calvin cycle.
Huh. Happy and enlightening.
The second stage of photosynthesis is the Calvin cycle. It takes place in the stroma of the chloroplast. It uses enzymes and intermediary molecules in a cyclic process to produce glucose. The first step is the affixation of a CO2 molecule to ribulose biphosphate, a 5-carbon sugar, by the enzyme rubisco. This produces an unstable intermediary molecule. This is quickly broken up into 2 molecules of 3-phosphoglycerate. A molecule of ATP is introduced and reacted with 3-phosphoglycerate by the enzyme phosphoglycerate kinase to produce 1,3-biphosphoglycerate. This molecule is then reduced by NADPH into glyceraldehyde 3-phosphate by the enzyme glyceraldehyde 3-phosphate dehydrogenase. Glucose requires 2 molecules of G3P to form. However, we have not yet regenerated the initial RUBP investment. The same process described happens in 5 other locations. This way, there are a total of 36 carbon molecules available, 6 to create 1 glucose, and 30 to provide 5 carbon for each system. 6 molecules of ATP are used to create a new molecule of RUBP, and the cycle repeats.
Fascinating.
ATP ends up losing a phosphate group, turning into ADP. NADPH is oxidized, turning into NADP+. They are returned to the light reaction to facilitate those reactions again.